Give the warm-up a shot. See if you remember. Thank you, Notorious B.I.G. All right, brother. Yes, yes. Now, of course, you can do the algebraic method. Order of operations first. If there's anything you can add or subtract away from log base 5x plus 2, and then if there's anything you can multiply or divide away, et cetera, et cetera, et cetera. But if you remember just the inverse property here, I'm going to start with looking at, well, this is log base 5. So when I convert to exponential form, this 5 is still going to be the base of our exponent. I think it'll make a little bit more sense whenever we start doing it. Okay. Now here, we're going to have an exponent of x. And now I'm going to look here at the -4. If in the logarithmic function it's going down 4, then in the exponential, it will be going left 4. Here, if we're going left 2 in the logarithmic, then when we convert to exponential, it will be going down 2. Just look at how the numbers change roles and change signs. If you haven't done this one yet, give it a try.
Wait, I thought the inverse was put in the X.
That is exactly what it is. If you do it the algebraic way. If you're following this, the inverse property, it's a little faster. Now, by the way, this works on logarithmic and exponential. This will not work on that. It's always safe to just swap things.
Wait, so how would you start how to just red?
I will show you after notes because it takes a while. All right, looking at the next one, g of x is equal to base 4 raised to the x minus 3 plus 2. So since we're converting from exponential to logarithmic, I'm going to write the word log. Base 4. Okay, here with the x, looking at the exponential function, it is going up 2. So here it is going to go right 2. Here, looking at the exponential function, it is going right 3. So when we convert to logarithmic, it should be going up 3. That's the faster way to convert from exponential to logarithmic and logarithmic to exponential. You just remember those steps. Okay, now the new stuff. If you'd like to see the algebraic method, swapping x and y and then solving for y, just talk to me after notes and I'll show you. That's a little bit faster though, if you'll just memorize those steps. Okay, for example 1, today we are solving logarithmic equation, and it's really pretty easy. First thing you want to make sure of, and this is probably going to be the case in every scenario, are the bases the same? And they are here. We have log base 5 of y equals log base 5 of 16. They're the same. When they're the same, you don't really need them anymore. So get rid of log base 5 and just keep what's left over. There's nothing to solve here. That's your answer. Y equals 16. That's it. Okay, looking at B. What's the base for B? 10. Very good. If you don't see a base with a logarithm, it's base 10. Remember that. Since we have the exact same base here on both sides of the equal sign, just drop the word log. Take what you have in parentheses, set it equal to one another, and then solve for x. This was just a basic two-step equation. That's what we're doing today. We're going back to pre-algebra and we're solving equations, except it just has the word log in them. All right, here we have not the common log, but a natural log. What is the base of this function? Hint, it's a letter. E, very good. This is base E. That will help you if it tells you to convert from the logarithm or natural logarithmic to its exponential equivalent. That will help you remember that this is base E. Okay, well, both of these are the exact same base, so drop L in. And now we solve. Since we have x squared in this problem and neither of these terms have an x attached to them, I'm going to go ahead and swing this 4 over there. Take the square root of both sides, and remember, if you were solving for x squared or y squared or whatever in an equation, final answer is plus or minus the result. So here we have plus or minus 5. Plus or minus 5. Example D. Since we are dealing with the exact same base, I just went ahead and dropped them. Don't need them. We're just solving this function here. Now, what you want to do if you're in a scenario such as this is we want to multiply both sides by the denominator. We're going to multiply both sides by 3x minus 2. When we do that, it's going to cancel out on the left side of the equal sign. Make sure and distribute that 2. Combine your like terms and solve. Solving equations. That's what we're doing. What do you think? What? We learned last class that the expanded version of logarithms, if we are dealing with subtraction, when we condense it, what is it? Divide. Very good. So if you see something like this, you're going to have to remember your rules of logarithms. So what we want to do is we want to change this portion, the left side of the equal sign, to look like a division problem. 5x plus 13 over 6 is equal to 3x. Multiply both sides by the denominator and begin solving.
Wait, so you're multiplying the 6?
Multiply both sides by the denominator. This is exactly right. See, question? Good. All right. N. I say N, maybe because of the L in. Okay, F. Weird. What is the addition property of logarithms if we are going to condense? Multiplication. Good. Now, warning here. We have a 2 in front of Ln. What is that going to do to the x? So when we condense, this is now x squared times 3, and that is equal to 27. X squared times 3, more commonly known as 3x squared. I'm going to go ahead and divide the 3. Now here's some papers flipping over, and that's great. Y'all help me. I think this is is this like the next section? It is. Okay, I'm about to show you something. Watch this. Do you know what you're supposed to do with every single time you solve a problem in math? You know what you're supposed to do with that number? You're supposed to plug it back in, which we rarely do because most of the time they work. And I don't want to take the time, you don't want to take the time to do that with every single one. With logarithms, you're going to want to check. Because here's what you cannot have. If we took +3, plugged it in here for x, that's okay. We can have that. If we were to take -3 and plug it in here for x, that we cannot have. That ln of that portion of the logarithm cannot be negative. Otherwise, it would make it undefined. So your only answer here is 3. Your extraneous answer, if it asks you to list the extraneous answer, that pretty much means what is the answer that doesn't work? Your extraneous would be -3. So your only answer here is 3. All right, for example, G, don't solve it. I just want you to condense it. Just set it up as if you were going to solve it. Get that? Good. Let's move on. H. Now, try and solve that one on your own. Where do you come? Where's the Y? Truthfully, I've been doing this a long time, so I recognize the pattern. That's the truth. 2. We have a trinomial here. We have 3 terms that aren't similar. T squared, T, and -6. And that is the case. Set it equal to 0. See if you can factor. All right. How'd we do? Good. Are both of those an answer? No, very good. The only answer is 3. Now, y'all, that doesn't mean that your answer can never be negative. Just whenever you plug it in, the results can't be negative. All right. So I don't want you to think that just if we ever have a negative solution that's extraneous. Not necessarily. Plug it in and see if the result is negative. So that wouldn't be extraneous. For this one here, we're not going to work it to its completion, but I at least want to show you how you would set something like this up, okay? Because I think that once we have it set up, I think we're going to have an idea of what to do. You would want to do butterfly method, and when you do that, make sure you write it like this. Okay, that's the setup. Then what would you need to do to both sides of the equal sign? Distribute, FOIL, combine like terms and solve. Okay, which we've been doing for a very long time. I just want to show you how to set that one up. Okay, now we're going on to something a little new, but not really. Let's go look at example 2a. What is the base of this function? And that's going to help us solve this. Because log base 10 of x equals -2. In its current state, we can't solve it. But if we convert it to its exponential equivalent, we can. So that would be, here we have base 10. It's still going to be the base when we convert to exponential form. these two terms are going to switch sides of the equal sign. Negative 2x. I'm just putting a blank here to show you that we have to fill that space. So we have 10 to the negative second power is equal to x. What is 10 squared? 100. What is 10 to the negative second power? Flip it.
Oh,
1 over 100. Okay, remember, a negative exponent does not mean that your answer is going to be negative. In a way, it just kind of means flip the answer. Okay, 10 squared is 100. 10 to the negative second power means 1 over 100. That's your answer. 10 to the 1/2 power. 10 to the 1/2 power. Would not what that means. That means square root. Yeah, 10 to the 1/2 power would mean the square root of 10, which I don't even know what that is. All right, what is our base here? E, there you go. So let's convert it to exponential form. Now, I believe on your notes, it says leave your answers in terms of E or something like that. What that means is you don't necessarily have to have, like here we have 1 over 100. You know what that is, okay? E to the negative 1/8. I don't know what that is without a calculator. It doesn't want you to use a calculator. It just wants you to leave your answers something similar to this, but we want to take care of the negative exponent. So we would just simply need to change it to this right there. On your delta math, you're going to have some problems that involve E. You would just leave your answer like that. That's okay. That's the answer. Don't worry about, do not plug it into a calculator or whatever and get the answer. It actually might count it wrong. It wants the final answer like this. Okay, with example C2 or example 2C, whatever, we're going to need to subtract the 6 first. Divide both sides by 3. And now from here, see if you can get the final answer in terms of E. That would be your final answer there. 1 over E to the 2/3. Okay, what base are we dealing with here? Or 2E? Did I miss that?
Oh, wait, no. That's for D.
You're right. I'm skipping D.
Okay.
Don't worry about D. Let's look at E.
Okay.
10. We have base 10 here. Good. All right, this one's a little bit different because we don't have log on both sides. So we have to operate this one just a little bit different, but it's really not too bad. Whatever your base is here, just swing it over to the other side. And now the right side of the equal sign is 10 to the first power. So whenever we go to condense this, this is what it's going to look like. X times x plus minus 9, sorry, I almost said plus, is equal to 10 to the first power. 10 to the first power is just 10. And then you would solve. I think we know how to solve those types of problems, so we won't worry about that. I just want to show you how to set it up. All right, for example, F, don't worry about solving it. Just see if you could condense it very similar to what I did here. Yeah, you know, it's solved. So it looks like we would have x plus 3 2 minus x is equal to 4 to the first power. Did y'all get that? I think you're right. Don't forget to submit your notes on my Canvas page. Go to Delta Math, do the assignments. If you need help, let me know.
Wait, that question is good. Actually, I did this wrong. Just as we're cutting to the back, I thought you were looking at it.
So here's what I'm gonna do. I'm going to, and then I'm going to solve the way that we originally. planned.
And then you also go over again like the simple steps like you did.
I can.